All right, welcome to 4-2. Let's go to the notes. What do you say? All right. Um, so, uh, angle measurement postulate's the first thing up, leading off for the Dodgers, the bottom of the first. This is to angles what the distance postulate is to segments. Remember, the distance postulate said that a segment has one distance, basically, right? Okay. And same thing for angles. So if there's an angle with a measurement that we'll just call R, then it's going to be something greater than zero, and less than 180. Can it be 180? No, less than 180. Okay. And R is basically the measure of the angle. Okay. So remember, an angle versus its measure. An angle is a set of all points, right? It's the two non-collinear rays, and the common endpoint, the vertex, right? Whereas the measure of its angle is a real number between 0 and 180. Okay. We also have the angle construction postulate, which basically is very similar to the point plotting theorem for segments, okay? And that basically says that for each ray AB on a half plane, okay, right, on the edge of a half plane, remember a line creates two half plane, here's H1, okay? H2 would be down here. There is exactly one ray AP that lies in H1 such that the measure of angle PAB is equal to R. Okay. Now, what is that basically saying? It just says that for every single possible number between 0 and 180 coming off of this ray AB, there's only going to be one angle that has that. Okay. All right. By the way, notice we don't need to put the degree sign because when we say the measure, that means the measure in degrees. So that's kind of assumed there. That would just be repetitive. Okay, cool. So angle addition postulate is similar to betweenness. Remember how we said a part plus a part equals a whole in terms of segments? Part plus a part equals the whole for segments. Same thing with angles. So this is the angle addition postulate. And it basically says if point A is in the interior of angle GOT, then the measure of GOA plus a measure of angle AOT is equal to the whole enchilada, the measure of angle GOT, okay? Now, it's very important, which is why there's a star by it, that A lies in the interior of angle GOT, okay? So it's part plus a part equals the whole, okay? All right, adjacent angles. Angles that share a common ray and endpoint, but have no interior points in common. Okay, so if you look up here, angle GOA, angle AOT, they share a ray, right, ray OA, but they have the same vertex, right? And they have no interior points in common, right? If you're in GOA, you're not in AOT, okay? Linear pairs. Linear pairs are basically pairs of angles where they form up the entire side of a line, okay? So if you have ray AB and ray AD that are opposite rays, right? So they basically form a line, right? And AC is any other ray, then we know that angle BAC and CAD form a linear pair, okay? Now you might think you know what the angle measures of those two add up to, and you're right, they do. We'll get to that in a sec, but it's officially not in your geometric sphere of knowledge yet. Okay, so looking at this diagram here, excuse me, name two pairs of adjacent angles. Oops. Okay, so take a look at that and tell me what two pairs of adjacent angles, two pairs. So one pair of two and then another two. Go ahead and try that. Okay, so one was HME and HMO. That would be a pair, right? And then there would be these two as well. Okay, so those are what we got. Awesome. By the way, would we also have adjacent angles with OHP and EHP? Absolutely. So there's a whole bunch. I don't even think I've listed all of them here. All right. Moving along. Here we go. Supplementary angles. Okay. If the sum of the measures of two angles is 180, then the angles are called supplementary, and each is a supplement of the other. Okay. Okay. Does it say anything about them having to be like, adjacent or in the same diagram or anything like that? No. So I could have an angle way over here that's, I don't know, 100 degrees, and I could have one, in the other room that's 80 degrees. Those would still be supplementary. Okay. All right. Complementary, same exact concept, except the two angle measures sum to 90 degrees. Okay. And I've got a real easy way for you to remember this. Okay. Watch this. You're going to love this. Okay. Isn't 90 half of 180? Or in other words, two 90s makes 180, right? So like two C's make an S. So there's 90, there's a C, and then there's another 90 to make an S. Okay, so anyway, I don't know if you like that or not, but whatever. It's there to remember. S, 180, C is kind of half of an S, 90. All right, lovely. So supplementary angles, definition, some two measures of angles add up to 180. And by the way, if you know that the sum of the measures of two angles add up to 180, then those angles are supplementary angles. So it works both ways. Okay. So here's some examples. Okay. Here's some notation that I made up. Rather than writing out supplementary, especially when you're doing like proofs, you don't want to write that out. Just use a big capital S. Okay. And that's what that will mean. And a big capital C for complementary, right? So if you have that two angles are supplementary, that means their measures add up to 180, okay? You wouldn't say the measure of angle A is supplementary to the measure of angle B. That wouldn't make sense. The two sums add up to 180, okay? All right, awesome. The supplement postulate basically says if two angles form a linear pair, then they're supplementary. Or another way of putting that is linear pairs are supplementary. I call that LPS. So when we get into doing proofs and a little bit later in chapter 4, LPS we all know is linear pair supplementary. It just makes it a lot faster to do these, okay? All right, so we can see 1 and 2 are a linear pair. We therefore know that they are supplementary, which means their measures add up to 180. Okay. Is the converse true? What do you think? In other words, if we know that we have supplementary angles, does that mean they form a linear pair? Hope you said no, because not all supplementary angles are linear pairs. In fact, I think right up here, here's two examples that these two add up. They are supplementary, but they do not add up. I mean, they are not a linear pair, right? Okay. Awesome. All right, here's some questions. See if you can answer these. If an angle is a measure of 25, what's its supplement? Hopefully you're calculating in your head. Hopefully you're going, 180 minus 25 is 155. Good. Awesome. Way to go. Okay. And then second one, if an angle is a measure of 110, then what's its supplement? We got 70. If an angle is a measure of X, what's its supplement? Wait, what does that say right there? Oh, hopefully you got 180 minus X. Did you? I hope so. Okay, so now we're going to go ahead and do some of these word problems. Here's an example of one. So again, go to your happy place, relax. You can do word problems. You got this. Not that bad. Okay. 3 times the measure of an angle is 25 more than twice the measure of its supplement. Okay, find the angles. Again, you want to assign defined variables. So let's say X we represent as the angle, or the measure of the angle, then 180 minus X would be its supplement, right? Remember this up here? Okay. So if you read carefully, 3 times the measure of an angle would be what? 3X is equals 25 more than twice the measure of the supplement. So you want to multiply 2 times 180 minus X, that's twice the supplement, and then 25 more, we would add 25 to it. And then you go about solving that. I'm not going to worry about that right now. I know you can solve that. Otherwise, Ms. Dickinson will be very upset with you. All right. But now you can try these, okay? So go ahead and give the first one a shot. The larger of two supplementary angles is 4 more than 7 times the smaller. Find the measure of each angle. Pause the video, give it a shot, and then I'll go through it. Okay, I'm back. Hopefully you got it right. You can check your answer, did you? Hopefully. Anyway, I set X to be the larger, 180 minus X to be the smaller. Did I have to do it that way? No, I could have reversed it when it made a difference in terms of the final answer. Hopefully you got X equals 7 times the quantity 180 minus X plus 4, if you set it up the way I did, and then did the math and got 158 for X, which means the smaller one would be 180 minus 158, which is 22. Okay, you digest that for a sec and then go on to number 2 and try that one. Okay, so I set X equal to the measure of the angle. So 180 minus X would be its supplement, and the complement would be 90 minus X. Okay, so the way to set it up is 180 minus X, this is supplement, right? 4 times the complement would be 4 times the quantity, 90 minus X. Distribute, solve, and then we got 60 for X. We need to find its complement. So obviously it would be 90 minus 60, which is 30. Make sure you answer the question that was asked. Okay, number 3, go for it. All right, I'm back. So again, set X equal to the measure of the angle. So in this case, hopefully you set it up as 5 times the complement, which would be 90 minus X, is 40 more than twice the supplement, 2 times the quantity, 180 minus X plus 40. And ended up getting X equals 16 2/3. I thought, oh my gosh, I don't know if that's right. And therefore, if we know that, then we just need to subtract that from 180 and get 163 1/3. Again, remember, you can check these by plugging in or just think about it. Figure out what the complement is, right? Isn't it going to be 73 1/3? Multiply that times 5, and that should be 40 more than this doubled, okay? All right, now try number 4. Some of the measures of a complement and a supplement of an angle is 160. Find the measure of the angle. So I'm going to set X equal to the measure of the angle. So 90 minus X would be the complement, 180 minus X would be the supplement. Add them together to 160. Do the math, and hopefully you got 55. Again, you could have just left X equals 55 or just written 55. Degree sign is kind of not really all that important. All right, and then lastly, try this one. Okay, so I assigned and defined a variable. I should have written X equals angle measure, but anyway, 3 times the measure of an angle. Notice is 30 less. I ended up adding 30 to that just to balance it out. I like to give to the poor rather than steal from the rich. But, you know, I could do the other 2. You could have had minus 30 over here. And anyway, when you solved it, you should have gotten X equals 66. Now remember, you had to find the measure of both angles, right? So you need to find 66 and 180 minus 66, which is 114. All right, well, that does it for 4-2. Have a great day. I hope you enjoyed learning a lot more about supplements, complements, linear pairs, adjacent angles. A lot of meat in this one. Easy, not too tough in terms of it, but plenty in there. So anyway, have a great rest of your day.